Okay, so last time we have looked at the probability problems with the coin tossing or flipping a coin, and this time I will show you how does it work where the die, like six-sided die, is tossed. We will try to answer the question listed here. So what's the probability of getting it to if we toss a coin? First of all, let's have a look. What's our sample space? So the sample space, the all possible numbers that we can get, as you see from the photo as well, it's the numbers that we can get. It's a 1, 2, 3, 4, 5, and 6. So let's say if we want to answer the question, what's the probability of getting a 2? Then there's only one possibility of getting the 2, as you see here. So meaning that what we will do, our P is going to be equal to 1 divided all possible outcomes that we can get. Is a total is here, number 6. So which gives us around like 1666 is repeated. So if you round it up, we will get something like 0.167 in total. So that's a probability of 16.7%. So it means that there's a probability of 16.7 of getting a 2 when we toss a die. So the second question we are asked to answer, what's the probability of getting 3 or 5? Okay, let's have a look. How does it work with this? So again, so what are the possible outcomes? There's the 2 favorable outcomes out of 6, which is 3 or 5. So meaning that we're gonna divide 2 divided to 6, which is 1 divided 3, and this gives us around 0.0 repeated. That's 33.3 of chance of getting 3 or 5 if like when we toss a die. So now what about so what's the probability of getting number that's at most 4? So what does this mean? So the most 4 here signifies that the possible outcomes that leads to particular problem listed here. What's at most 4? It means that we can get numbers that less than or equal to 4. So it means we can get 1, 2, 3, and 4. So the probability of this event occurring, we can say, let's say, so here actually what we say, P, I mean the numbers that we can get, okay, the natural numbers, because otherwise it can be negative as well. So let's say it should fulfill the requirement of to be less than 4 or equal to 4. Okay, let's take this out, meaning that we can so it can be, let's say, so we said that we have 4 favorable outcomes divided to 6, so which gives us 2 divided 3, and which is approximately is 0.667. so it means there's 66.7 of chance of this event occurring. So meaning that we can get the number that's at most 4. Okay, the next question is that what's the probability of getting a number that's greater than 3? Okay, let's have a look at that. So greater than 3, It means that this is our outcomes that we can get, and numbers that are greater than 3, so it means includes the numbers 4, 5 and 6. So it means that the natural numbers which is greater than 3, so we have 3 favorable outcomes out of 6. So it means we have 1 divided 2. It means we have 50% of chance event of this event occurring. I will just correct this one. So there's a 50% of chance that we can get the number that's greater than 3. In our last question, we have been asked to answer what's the probability of getting number that's less or equal to 5. So here we need the natural numbers that's it's actually less than. I did a mistake here. So numbers that less than equal to 5, that's everything except the 6. So it means 1, 2, 3, 4 and 5. So here in total we have 5 favorable outcomes. So out of 6 potential outcomes, so it means 5 divided 6, which gives us 0.833. So 83.3 of chance as that we can get the number that's less than or equal to 5 when we toss a die. Okay, so actually the probability is not that complicated. So everything, you just try to write it down and just get some photos to understand, and after it's quite straightforward.